In this edition of the Data Intelligence Lab podcast, we talked to Doug Gray, the co-author of Why Data Science Projects Fail. With no hype and just hard truths, Doug's going to debunk the myth that failure is about technology. The real obstacles that he points out, so many of them are human: communication, resistance to change, bad expectations, and a focus on technology instead of business value. This will be a terrific episode for anyone interested in how to turn decision intelligence technologies into real business value.
People tend to overestimate scope. They underestimate how long it's going to take to do things. They overestimate how good their team is at programming. They underestimate complexity. Then they overcommit on scope. These are all fundamental tenets of project management that foil IT people. Data scientists need to climb the business learning curve and understand the business problem, the business process, the KPIs, the things that mean the most to the business people. And the business people do need to step up to a certain extent and understand, at least be engaged in those validation scenarios and be willing to take the time to invest.
Hello again, and welcome to another edition of the podcast. I'm here with my partner in crime, Michael Watson, and our guest today is Doug Gray. Doug has had a distinguished career in operations research, data science, and artificial intelligence, going all the way back to the legendary American Airlines Group from the late 80s and the 90s, and then including stints with Travelocity, Southwest Airlines, and most recently Walmart. There's probably a bunch of things that I haven't mentioned. He's also the author of a brand new book called Why Data Science Projects Fail: The Harsh Reality of Implementing AI and Analytics Without the Hype. I'm going to turn it over to my partner, Michael Watson, to ask our first question.
All right, Doug, thanks for joining us. Let's start off with just the elevator pitch. Like, what's your elevator pitch for your book? Like, who's the audience? Why'd you write it? And give us your thoughts on it.
Well, thanks, VJ and Michael, for having me. Greatly appreciate it and happy to be here. You know, about 5 years ago, I started seeing a lot of articles that were basically proclaiming that 80% of data science projects fail. And I was really shocked by that number because fortunately that hadn't been my experience. I've had my share of failures, but I really wanted to dig into that and understand. So I kind of did my own research. I talked to colleagues. I read a lot of papers. I looked at my own experiences, and I came up with a top 10 list. And I actually wrote some PowerPoints and presented that, got good feedback. And people were really craving information about why data science projects fail. And that turned into a series of articles that then turned into the book. And the real purpose for the book is to increase increase success rates, increase success rates by learning through failure. And it turns out, psychologically, we not only learn more from failure, we learn more from the failures of others, because there's not the stigma there that we have to deal with, that we have to, in our reptilian brain, deal with the fact that we messed up. So we read about other people's failures, and really we wanted to increase success rates and increase the amount of business value and economic impact. And frankly, the audience for the book can be students that are learning data science in university, that are maybe doing capstone projects, that are getting ready to venture out into the real world for the first time. We want them to be aware of some of the non-technical challenges that they're going to face. It could be for young professionals that may be struggling with success rates of their own projects. And lastly, it could be leaders that are struggling with, why are all my data science projects failing, or the majority, or why am I investing all this money in software and hardware and not getting the return on investment that I would like. So that was really the motivation for the book, was to increase success rates by learning through failure for those particular audiences.
Excellent. Doug, I want to kind of jump on that. I know you guys organized the book around a group of classifications around things like technology and process and organizational maturity, which we'll talk about later. But my passion in this is sort of the people side. So I'd love to have you kind of give us a sense or a summary of what you guys found to be the biggest people issues in your people chapter, and maybe some examples or stories to bring that to life.
Sure. So, what we found, not surprisingly, is the issues of failure are not about technology. Servers work, software works, the math, a lot of it's been around for hundreds of years or at least decades. That's not the problem. It's the human factor here. And uh, I would just list off, and I'll give you some examples. I'll list off kind of the top five human factors. Number one, communication. Number two, change management. Number three, project management. Number four, unrealistic expectations. And number five, excessive focus on technology. Those are the kind of the non-technical human factors. From a communication perspective, I'll just cite some examples of data scientists talk in terms of algorithms and models, and business people talk about processes and KPIs, and they really don't speak the same language. And there is an inherent breakdown in communication, and we need to bridge that and create a common language and a common lexicon. And really, that usually centers around business value, key performance indicators, key business metrics. What are the key business questions that we're trying to answer? What's the problem that we're trying to solve? And then what is, or the decision that we're trying to make? So communication is really key. Storytelling is key. One of the factors in storytelling is using before and after stories. Here's the way the world worked before the model. Here's the way the world worked after. And hopefully there's an economic impact in the after scenario that everyone, including even executives, can rally around to communicate. Change management in general, people don't like change, right? And there's nothing more invasive than changing the way people do things. I've had two examples in my career. One was at a major airline where we were going in to revamp the jet fuel forecasting and planning and purchasing and inventory management. And they had been using a spreadsheet for 30 years that literally had 150 tabs and was fraught with errors. And they were dead set on changing that. They did not want to move away from that, even though they probably knew in their heart of hearts there were problems, right? But uh, one of the big aspects of change was really summarized very nicely by a guy named Gene Woolsey, who is a paragon of excellence in the academic world of OR and consulting. And he said a manager would rather live with a problem that they can't solve than implement a solution that they can't understand. And that really is crux and core to this notion of change management. We have to bring everyone along with us. We have to bring along the end users. We have to bring along the managers, the executives. And the way we do that is through these before and after pictures, through a lot of validation and verification exercises where we show here's the result you get with your 150 tab error prone spreadsheet. Here's the result that we get with our new model, and literally go case by case and point by point to show here's how we got the $20 million savings over what you did. And it's amazing when you flip that switch from resistance to acceptance, and not only acceptance, but embracing the new solution and using the new tool and getting rid of what's been there in the past. Project management, I'll just say that most people, unfortunately, are optimists, and that's unrealistic. I started out my career as an optimist. Now I define myself as a pragmatic optimist. People tend to overestimate uh, scope. They underestimate how long it's going to take to do things. They overestimate how good their team is at programming. They underestimate complexity. Then they overcommit on scope. These are all fundamental tenets of project management that foil IT people, where also the 80% failure rate is there, according
Right.
to Standish Group and the Chaos Report, if you've read that. Um, Unrealistic expectations, I think everybody wants to get a big win. Everybody wants to save the company a lot of money. But if you come in on 20 billion in revenue and say you're going to save the company $100 million with your project and then you save 10, you're going to fail, right? If you do the opposite of that, you might be considered sandbagging if you say 10 and get 100, right? So in the book, I actually outline a process by like identifying what's the maximum potential realistic benefit, and then we take a fraction of that, and then we take yet another fraction of that. So there's this spectrum that we talk about of expectations that ranges from, on the one hand, overcommitting and epic fails to sandbagging. We want to get there somewhere in the middle, and maybe borrow Jim Collins's big, hairy, audacious goal, something that's a little bit of a stretch goal, but be realistic when you're setting expectations. And then lastly, the excessive focus on tech. I think it's fundamentally wrong to start with something like an AI project and say, we really want to do something with computer vision. We're fascinated by computer vision. We went out, we bought all these cameras, we've got all these algorithms, we've got convolutional neural networks. Let's go out and do a project. And there was a project at a major airline that I'm familiar with that said, we really want to use computer vision to help us reduce boarding time. And the way we're going to do that is we're going to video record everybody coming down the jet bridge, and we're going to look at their bags, their carry-on bags, and we're going to estimate the volume of the bags. And then by looking at the bags, we're going to figure out how fast the bins are going to fill up. Well, that seems like a reasonable thing to do, and it turns out the technology is really good at that. You can estimate volume, and you can estimate how much capacity and how fast it's going to fill up. The problem is that there's already an analog solution that does that really well. It's called a flight attendant. And they stand in the middle of the cabin, and they have just as good of an algorithm or better of when the bins are going to fill up. And they get on the horn and say, start checking the bag because we're out of space, right? That project spent hundreds of thousands of dollars on consultants and software and hardware and cameras. And they did 3 pilots at 3 different airports. And they had zero appreciable impact on boarding times. At Walmart, on the other hand, we picked the problem using computer vision, but we started with the problem, and that is bad packaging. As packages are flowing through our distribution centers, if the packages are damaged, we have to send them back. That problem, I can't tell you how big the number is, but it's got a B behind it.
Yeah.
Every year, bad packaging costs Walmart a single-digit percentage of sales. And
Whoa.
we use computer vision to identify damaged packages and then use that to give feedback to the suppliers to say, you need to fix your packaging of, Pampers, diapers, or whatever, because it's killing us. That's a real live project that's going on today in my group at Walmart. So we start with the business problem and then use computer vision, not the other way around.
Excellent. Mike?
Perfect. Yeah, let's. I want to kind of talk about, I think the people part also gets into something I think you're famous in circles for talking about, is that when you look at these projects, you should think every dollar you spend in the algorithm, there's $100 in the non-algorithm part. And I guess some of the people is part of that, but there must be more to it too. And I think this is just a good insight to keep algorithm people honest, thinking about all these costs. So what are some of the other costs that go into that, in addition to the change management work and all that?
Yeah, so the number 10 reason on my list of why projects fail is what I call getting from sandbox to production system, right?
Yeah.
Any data scientist can sit down with a Jupyter notebook or a cloud instance and literally build a model in an afternoon if they've got the data. And I've verified that with my own teams. And I ask them, how long did it take you to build the model? A day, a week, But then to put that into production, that number, $1 to 100, was a number that I came up with based on my own experience, where I said for every dollar to build the algorithm, it's 10 to 100, right? 1 to 2 orders of magnitude. That was based on my experience of
Right.
projects. Then MIT recently came out with a paper that verified that and nailed the 100 number and said, if you're going to move something into production, it's 100. I'll tell you why that's the case. In order for that model and that algorithm really to generate value, it's got to be running consistently, reliably. It's got to be available. It's got to be embedded into the systems and the ecosystem of the company, the process ecosystem, the IT ecosystem. Most of the time is spent integrating your model with many different data sources because the data is not all necessarily in one place.
Yep.
We have to then make those data pipelines very robust. We need then the infrastructure to hold that data. It could be a cache, it could be BigQuery in Google Cloud, it could be in a data warehouse, it could be in a data lake. Uh, we have to then integrate not only the data, but we have to integrate with systems, right? Because the model that runs and spits out the answer is not what the end user sees. The end user has to see that through whatever enterprise app that they're using. And the example that I state in the book is when at Southwest Airlines we built a real-time airline recovery system. It's called the Baker. It basically helped us improve our on-time performance dramatically in winter storms. The data is in the book, and I've got some data here. But the model building started in 2008. The system didn't get deployed until 2015. What were we doing for 7 years?
Yeah.
First of all, we were building better and better versions of the model because we kept learning. It was a very, very complex problem solved with multi-commodity network flow with side constraints. Very hard problem to solve. But most of the time was spent building the data sources, building the data caches, building the data pipelines, because literally we need to be able to hit a button and get a snapshot of where all of our 800 aircraft are, where all the passengers are, and figure out how to flow them around the bottlenecks to get them to where they're supposed to be using a combination of delays and cancellations. And then lastly, we had to integrate it with the system that was going to actually display those results. So it's time and labor to
Yep.
get that built of your team, the analytics and algorithm team, but it's also the time of the data engineering team, the time of the systems team. Frankly, even at Walmart, when I build, my team builds a model, we go into the backlog of other teams, right? That they've already got their agenda. They've already got their backlog. They've
Right.
got their roadmap. You've got to
Yep.
somehow wedge your stuff in and get it prioritized. Sometimes that process can take months, to get prioritized. But hopefully the business value carries the day. But I would say the last dimension is testing, right? So when Fred Brooks wrote his book, The Mythical Man Month, he talked about the rule of thumb was you should spend uh, a third of your time on design, 1/6 of your time coding, and half of your time testing. I would go so far to say that that rule, in theory and in practice, still holds true. We spent an inordinate amount of time testing all of the interfaces, testing the use of the system. We had a huge change management challenge where there were some old crotchety guys that didn't want to use the new system.
Right.
We had to run a bake-off for a few months. We basically had to run a bake-off for a few months where the uh, the system that we built was only winning about half the time, and humans were winning half the time. And they were like, "See, I told you so. I'm better." Well, then
Right.
we just kept making the system more intelligent, and the system climbed the S curve, the learning curve, to the point where no human could ever beat our solution in recovering the airline. And by the way, it would take the humans 6 hours to do it. It took us 30 minutes by automating and
Yeah.
streamlining and optimizing, right? So hardware, software, development time, integration point, endpoints of systems and data, and then test, 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 and validate, validate, validate until the cows come home. That's
You
how
know,
you get to 10 to 100 times.
I like what you said too, that the testing or the testing and the change management go hand in hand. Because I think sometimes you have a tendency to think change management is just all about people and testing is just all about technology. But really, you kind of need, your story illustrates you really need both. You need to work with the people on the people side of that. And you also need the technology to make it sort of come together. Like you can't just tell people it's good. You have to actually show them and run tests to sort of make sure it's true.
We literally had one, two, three, four engineers and a project manager, all of which had PhDs in a room building that system. And we had two subject matter experts that were expert dispatchers with 30 years. One had 30 years of experience, one had 10. Those guys were the source of all of the intellectual property that had to be built into the model. And then those guys were the ones that actually took it out to the floor and sold it. Because when guys that look like me show up at systems
Right.
operations control, they do not want to hear from me. They don't want to talk to me. They don't want to hear what I have to say. But one of their own people with 30 years of experience, who is a supervisor at dispatch, right under the chief of dispatch for the airline, says, this is the new way to do things. Let's give this a try. Makes all the difference in the world.
Perfect.
Doug, I want to kind of come back. You've kind of bridged nicely into that. I feel like the people that are taking on the responsibility for using decision support, decision intelligence technologies have more stuff coming at them and more kind of mental load that they're wrestling with than ever before. Is this something that you've observed, and do you feel like this is an issue for us in the kind of analytics, data science, AI community?
Are you talking about business people or data scientists?
No, business people. The business people that are inheriting our systems and have to work with them.
Yeah. So there's definitely a step function, for people that have to learn how to use a new tool, right?
Yeah.
They have to trust, and they don't like black boxes, right? Just like I said earlier, the manager would rather continue to live with a problem they can't solve versus implement something they can't understand, right? So we have to help them see into the black box. We have to take the lid off the black box. Now, does that mean that we're going to sit there and explain logistic regression to them and how that works to build a binary classifier? No. But we are going to sit there and go through each one of the betas, which are the variable impacts of why this particular variable is more meaningful than this one in predicting the probability that somebody's going to have a stroke or they're going to readmit to the hospital or whatever. So there's definitely data scientists need to climb the business learning curve and understand the business problem, the business process, the KPIs, the things that mean the most to the business people. And the business people do need to step up to a certain extent and understand, at least be engaged in those validation scenarios and be willing to take the time to invest. And no business person ever has to, or frankly should, need to become an expert in AI or OR, right? But they have to understand the way the model is working. And in my experience, the more you can do to make the way the model works look more like the way they do things today, it lowers that learning curve, right? And I'll give you a good example. Go back to our friend Gene Woolsey. He said getting to the optimal solution is actually less important than showing the user the answer in a form that they understand. And my first big project on aircraft maintenance planning and scheduling, that was a big success and saved the company $1 billion in today's dollars and avoiding unnecessary superfluous maintenance by optimally scheduling aircraft. They used to solve that problem on big sheets of paper hanging on the wall, colored pencils. They would draw Gantt charts, right? And every line on the Gantt chart was a hangar bay, and all the little colored pucks, on there were planes that were occupying space. And when we built our application on a Mac 2CX, which is like a PC back in the early 90s, we literally took those pieces of paper and put them onto the user interface, which was a color-driven Gantt chart that looks exactly what they used to do on paper.
Perfect.
The only difference was now there's an algorithm running behind that's automatically generating all the checks and scheduling them as close to their deadline as possible to get the check yields up near 100%, because their process, their manual process on the paper literally took them a month to generate one 5-year maintenance plan for 600 aircraft. We were doing that in 18 minutes on a Mac 2CX, near optimality, right?
And
But
and putting it out in a way that they could digest it. It was
yes,
super familiar
yes,
to them.
yes, yeah. And initially, we had the same change management challenges with them as I had with the fuel people. Nope, no way in hell are we using that computer. You're going to put us out of our job. And I said, A, I'm not going to put you out of a job because you need to give the model the inputs, right? It's even in today's world in AI using Chat GPT. Prompt engineering is what it's all about. If you write a crappy prompt, you're going to get a crappy answer. There's whole courses now being taught in prompt engineering, right? It goes back 30 years ago the same way. You have to give the model input, and then it'll do the best it can with the input. And then when you see the answer, you can adjust the inputs. And they do that iteratively and interactively using a technique called interactive optimization, where the model just really becomes a big calculator. And it's kind of a hybrid of an optimizer and a simulator. It's got an optimization algorithm, but you're basically running all these what if scenarios and simulating the schedule until you get one that you like, where you're not having any aircraft go over their deadline, but you got good yields in the high 90s, and that's how we saved $1 million a check on about 454 aircraft. But having that user interface made that transition easier for them, and now they've got this scrolling 5-year Gantt chart, on their Apple Mac desktop.
So this is I'm going to come back to your 80% failure number. This is a question I've kind of had, and since you've studied the topic, I want to get your thoughts on it. I'm not sure how to phrase the question, but I've kind of thought of these projects as like it's a little bit like venture capital. Like you as an executive, you sponsor 2 or 3 of these analytics projects, and you know that some of them are going to fail, but the big ones that succeed like really pay off for all the failures too. You kind of suggested that 80% is not the right optimal number. Is there an optimal percentage of failure that executives should expect? I don't feel like it should be 0% because that seems like you're just avoiding risk. Like, how would you think about that?
Yeah, that's a great question. So, 80% is a bad failure rate. 0 is also a bad failure rate. My number off the top of my head, you ought to be failing 10 to 20% of the time because we are in business, right? So it really depends on your context. If you're an R&D lab inventing new products at 3M, maybe you ought to be failing 50% of the time because you're really trying to create. But if you're in my world of solving problems, right, and delivering value, and my team has delivered as of just yesterday, I got the final numbers. Over the last 3 fiscal years, we've taken about $1.25 billion of cost avoidance out of Walmart's supply chain, right? I can't afford a 50% failure rate, but 10% of my projects do fail.
Yeah.
And they fail for a variety of reasons. Sometimes a new solution comes along that obviates what I was doing, right? So we were building a model to estimate a better ETA for our trucks coming from distribution centers arriving at stores. And it was a model based on Google Maps and Google traffic. And then we were adding some other factors in, like how long drivers take on their breaks and how many times they have to stop for a smoke or go to the bathroom or whatever. And it turned out that some people in the transportation division were implementing a device on every tractor trailer that would give you real time information on where the truck was.
Okay.
And they were building their own version of that algorithm and they didn't need what we did. So we took a year's worth of work and scrapped it. That was due to a lack of communication on the business people and the sponsors, right? Sometimes I think the big reasons that projects fail because you don't have the data. That's something that you ought to be able to figure out before you start the project. But sometimes you wade into it and you realize, like 30 years ago, I tried to solve the problem that we solved at Southwest in real-time airline recovery. We wrote down a beautiful model formulation and wrote down all the math, and then we waded into the project only to find out the data is not all in one place, and it's on a mainframe, and that was back when mainframe compute capacity still came at a premium, and we got boxed out. We didn't have the capacity to solve the problem. I think the other thing that happens is people underestimate complexity.
Right.
There are 3 big factors that go into prioritizing projects: the value, revenue increase, cost reduction, the cost to deliver the solution, but complexity. If you wade into a problem and find out, oh, this is a vehicle routing problem with time window constraints, That's TSP, that's NP complete. I'm not going to be able to solve that problem. UPS solves 55,000 vehicle routing problems every night in their Orion system for the next day's routing. But they use heuristics. They use yesterday's routes as an advanced starting point on tomorrow's routes. So you got to
And they
figure out a way
invested a
to,
ton of money building that system, right?
yes,
That did not come overnight.
200,
That was
250 million over
right.
10 years, but it saves 3 to 400, right?
Right.
So
Exactly.
I think that a failure rate of 10 to 20% for all the reasons that I stated in a corporate analytics group where you're trying to solve problems and make money or save money to pass on to the customer and shareholders, that's reasonable. If it's an R&D world at Apple in a lab using, making Siri better or something like that, some new algorithm to make Siri better, a 50% failure rate, might be acceptable. But I think there's definitely, it's non-zero for sure.
Yeah.
Well, I think we've got time for one more question, and I wouldn't want to get through this interview without talking a little bit, because you guys put such attention in the book to the importance of organizational maturity on success rates. Love to have you talk a little bit about how you think about organizational maturity for analytics, and share a little bit of some of the stuff in the book that talks about what a big factor that is in
Yeah.
success and failure rates.
Yeah. And this comes right out of my background in particular, because I was very fortunate. Better to be lucky than smart, and if you're both, you're really blessed. I landed at American Airlines in 1987, fresh out of Georgia Tech, with my master's in OR. And you talk about being in the right place at the right time. American Airlines already had a legacy of technological success. They invented Sabre, the computer reservation system, in 1958. Believe it or not, it was when the first Sabre system was built. And then Bob Crandall figured out a way to distribute that to travel agents all over the world and basically create strategic competitive advantage by being able to represent American Airlines capacity worldwide, globally, digitally to sell seats, right? So we were already standing on the shoulders of giants, right? So then we come along, we start building OR models. The yield management system that won the Edelman was recognized as one of the greatest achievements in OR in the history of the world. Tom Cook and Barry Smith have both been recognized there. And then I come along after that's already been done, and I get to learn from these guys that have already built systems that generate, hundreds of thousands of forecasts every night and completely automate the pricing for every bucket, every market, the number of seats we're going to allocate. I mean, that's how revenue management revolutionized post-deregulation airline world in the 80s, right? So that maturity was already there before I got there. Now, then we had another stage of maturity where we built things for American and took them out to try and sell them to other airlines. Nobody wanted to buy anything we built for American, because the first answer right after the demo, when you demo the system that you built for American to Lufthansa, they're like, that's not how we do it. We're a European airline. We're an Asia Pacific airline. We're a point-to-point carrier. We're not a hub and spoke carrier. What we were selling was our expertise in OR and our ability to build repeatable, scalable systems, right? And then we built versions of those tools for different companies and different regions around the world. So organizational maturity comes from two main factors, in my opinion: people and process. The people that have literally been there, done that, got the t-shirt, failed, learn from the failures, learn what works, learns what doesn't, and then they put those into place in terms of repeatable processes for design, estimating value, estimating complexity, and just managing that whole process end to end. And all the lessons that I have learned in my career, many of them were foundational to what I learned back at American Airlines. And just to put some numbers to it, if we say that the way companies are broken up into mature and immature, about 23% of companies are considered to be mature in analytics, leaving 77% immature. And what we found through research and through looking at articles that mention failures of either mature or immature companies, what we found out, the failure rate among immature companies was 90%, and for mature companies was 45%. And then the weighted average of those two gives you your 80% failure rate overall. So we quantitatively demonstrated the failure rate for immature companies is 2x, 90 versus 45, what the mature is. And it really comes from, if you look at the counter to what I just said, imagine you're the first data scientist hired right out of Stanford with your master's with no work experience, and you and your manager have been charged with doing AI or doing analytics. Guess what? There's a good chance you're going to screw that up because there is no infrastructure, there is no people, process, there is no methodology, there is no core competency, there is no center of excellence, there is no built up muscle memory, right? The muscle memory that comes from doing it wrong and doing it right. Organizational maturity really comes down to people and experience and expertise, and then that process, that repeatable knowledge. And the way we codify that is, I mentioned, center of excellence, community of practice, sharing of best practices. That maturity really has to be built like muscle memory over time. And that really is the differential between the failure rate.
That's perfect.
Excellent.
Yeah, go ahead, VJ. Yeah, this has been a great conversation. So let's wrap up with two things. If you can tell us like a favorite book or favorite author, and then at the end, just tell people where they can find your book.
Great. Thank you. So my favorite author by far is Tom Davenport. So Tom wrote the original book, Competing on Analytics, back in 2007, 2008 timeframe. He reprised that book in 2017 with an upgraded version. In between, he wrote several books like Analytics at Work, which gave more of a tactical implementation for analytics. Most recently, he shifted into AI. He had a 3-book arc on the AI advantage, working with AI, and then most recently, All In on AI. And if you're a leader and you're charged with putting together a strategy for your organization of how you're going to implement AI, All In on AI gives you a template for that, just like Competing on Analytics gave us a template for how to implement analytics, right? So I think that whole portfolio of books that Tom has written, that he's written some more since, but that whole portfolio of books really gives leaders and practitioners great examples of what to do.
Yeah, thanks for the conversation.
Wonderful. Thank you both for having me. It's a great pleasure to be here. My favorite topic to talk about. So hopefully that's helpful to your listeners.
No, this was terrific, Doug. Thanks so much.